Here is lesson 5. It's called rational exponent equations. So we are going to be solving for x in most of these, sometimes different variables, but either way we are solving. So part of the name of the lesson was talking about rational exponents, which again means fractions. So all of these are going to be dealing with exponents that are just different fractions. So a few facts about fractions. Number 1, what is the reciprocal of 2/5? So remember, a reciprocal, all you are doing is flipping the top and bottom. We do not change the sign. That was dealing with perpendicular lines in geometry. No changing signs for just a plain old reciprocal. All we do is flip the fraction. So part B, what do you get now when you multiply the 2/5 with its reciprocal? So multiplying, you can do it on your calculator if you want, but you should see multiplying with your reciprocal gets you 1. So 2, what is the reciprocal of -8/3? So again, reciprocal, all you are doing is flipping the fraction. The negative stays negative, a for number 1, the positive stayed positive. So now part B, what do you get when you multiply -8/3 with its reciprocal? So again, you could do it right on your calculator, but you should once again get 1. For 3, what is the reciprocal of 4? So for the first two, all we were doing was flipping the fraction. Right now I don't see 4 listed as a fraction, but technically numbers are over 1 if you don't see them as a fraction. So flipping, we get 1/4. Part B, what do you get when you multiply 4 with its reciprocal? So 4 times 1/4, we should get 1. So the fact that we're getting 1 for all of these is not a coincidence. That should happen every time you multiply reciprocals together. So being able to find reciprocals and knowing that they really just cancel each other out to a 1 is going to be helpful for all of today's lesson when it comes to solving. So if I gave you a question 4 and it says algebraically solve for x squared equals 4. Most likely, most of us know, all right, to get rid of the squared, I'm going to take the square root. But if I square root the left, I need to square root the right. So the squared and the square root cancel out. Radical 4 is 2, but the part that we tend to forget, if we ourselves are putting a square root into the problem, we are going to put a plus minus in front of our answer. All right, now we're going to learn another way to solve this. Another option. We just took the square root of both sides, but if you remember yesterday, we talked about the square root. Let's say we have the square root of x. We talked about power over root. That square root is the same thing as the 1/2 power. So really, taking the square root of both sides is taking the 1/2 power of both sides. But why are we taking the 1/2 power? Well, if we look at these two exponents now, their relationship, they are reciprocals of one another. And reciprocals, when you multiply them together, which is what has to happen here on the left, multiply to 1. Anything to the power of 1, we really don't have to show. So multiplying, flipping the exponent with its reciprocal really is going to end up canceling out your exponent, which is going to be more helpful when we get into some of these harder exponents that we're about to see. 4 to the 1/2 you can type into your calculator. Make sure you are doing the 1/2 as an exponent, and that's where we get our 2. Once again, it is up to us to remember the plus minus. So the trick here, if you're looking at your flipped exponent, if the denominator is any even number at all, you're going to put a plus minus in your answer. So just like it's up to us to remember that if we're taking the square root by ourselves, it is up to us when we flip an exponent. If the denominator of the flipped exponent is even, we need a plus minus in our answer. So let's take a look at a little bit of a harder problem. We have a to the 3/4 equals 27. So the trick for canceling out exponents is to take their reciprocal. But if I'm going to take the reciprocal of the exponent on the left, I have to use that same reciprocal exponent on the right. On the left, they cancel each other out. There are 2 exponents together, which indicates multiplication from our rules from lesson 3. And when I multiply, they cancel out to 1, and anything to the first is just itself. For the other side, you're going to just type this right on into your calculator. Make sure that you are using that as an exponent and you are not multiplying 27 4/3. So here we should get 81. One thing to point out, our flipped exponent, the denominator is odd, so no plus minus in your answer. Just take it the way the calculator shows it. So number 6, we have n to the 2/3 minus 1 equals 24. Step 1, we're going to add the 1 over. Just like in our radical equations, the first step is to isolate the radical. All these fractional exponents are types of radicals. So same first step, we are isolating whoever has the fractional exponent because it's just like isolating the radical. From there, to get rid of the exponent, we are going to flip it. Whatever you do to one side, you're going to do to the other. So on the left, they cancel. The right, you're going to type it in. And again, it's an exponent, the 3/2. We should get 125 from the calculator. And again, even denominator on the flipped exponent, plus minus in your answer. For 7, remember you have to think about who the exponent is attached to. In this case, because there are no parentheses around the 2r, that exponent is only attached to the r. The 2 is multiplying on after. So we are going to start by dividing the 2 to the other side. So you should get 343. From there, to get rid of this exponent, we are going to flip it, take its reciprocal. On the left, the reciprocals cancel out. On the right, we can type it into our calculator. If you get a decimal like this, math enter, enter, we want to make it a fraction. For this one, the denominator is odd, so no plus minus in your answer. Question 8. 4b to the negative 3/4 plus 10 equals 21 over 2. So again, we have to start by isolating the radical, which is the piece that has the fractional exponent. So I'm going to start by subtracting 10. So on your calculator, you can do 21 divided by 2 minus 10. You get 0.5 or 1/2. Either one works here. That's a very nice decimal. So if you want to keep it a decimal, keep it a decimal. Divide the 4. Again, there's no parentheses here, so that 4 is not included with the exponent. So 0.5 divided by 4. You get 0.125 or 1/8 if you're using the fraction. From here, reciprocal of the exponent. They will cancel out on the left. And 0.125 to the negative 4/3 power should come out as a nice 16. Denominator is odd, so no plus minus. Number 9. So I said that the fractional exponents were just like having radicals. So here now this one is just given to you right at the beginning as a radical. Step 1, isolate. Step 2, still isolate. This 2 is multiplying, so I'm going to divide it. So we get the cubed root of x to the 5th equals 32. Now the trick is to flip the fractional exponents. So in order to be able to flip, I am first going to have to make this radical a fractional exponent. So I get x to the 5/3 equals 32. Now I am ready to take the reciprocal. On my calculator, you should get a nice 8. Denominator was odd, so no plus minus. So number 10, we will be doing the same thing. We're going to have to get a power over root at some point. So we have 1 over the cubed root of x equals 3. Before I can convert and do any flipping, we do not want to solve with our x in the denominator. So my suggestion is put the 3 over 1 and let's cross multiply. So 1 times 1 is 1. 3 times the cubed root of x is just 3 cubed root x. That 3 is multiplying, so we're going to divide it over. So we really have 1/3 equals the cubed root of x. Converting this with power over root, we have 1/3 equals x to the 1/3. So taking the reciprocal, you should get 1 over 27. So if you go to type this in, decimal, so we get 1 over 27, and my denominator is odd, so no plus minus. Last question. I cannot move the 27 right now because the 27 is being included with this fractional exponent because it is in the parentheses. So my other option, my only option, is to get rid of it right from the beginning. Flip it on both sides. Do not distribute the 2/3 into that parenthesis. The only way we can distribute exponents in is if it is multiplication or division. Adding and subtracting, they cannot distribute. So we get 64 to the 3/2. And this one, we need to be careful. Your flipped denominator is even, so we need a plus minus. So adding the 27 over, you really have 27 plus minus 512. You cannot add these together to get 539 and say the answer is plus minus 539. That's not how these work. You're going to have to split it up. You get 27 plus 512. So there's the 539. And we're going to have 27 minus 512, which gets us negative 485, not negative 539.